This is the Chapter 5, Quiz 2, problem number 6. And it says, here's my polynomial right here. Show that x plus 1 and x minus 4 are factors of that polynomial, and then find the remaining factors of the polynomial. Now, one thing we kind of touched on a little bit, well, let's forget that right now. Let's see if we can find some remaining polynomials. So if I want to prove that these are factors, if this is a factor of a polynomial, it means if I divide it into, if I use this as my divisor, and I use the polynomial as my dividend, I'm going to get a remainder of 0 because it's a factor. And I told you it's a factor, so it better work out. The easiest way to do this is with synthetic division. You can do a polynomial long division, but polynomial long division, in my opinion, is cumbersome. So my 0 for this one is going to be -1, and my 0 for this one is going to be 4. So let's just use the -1 first, since it's the easiest. So I'm going to take my coefficients of my original polynomial, and I have every power there. I'm not missing any power. So my coefficients are 1, -2, -13, +14, and +24. I'm going to do synthetic division with -1. Let's see what happens. It better work. That's all I have to say. Bring down to 1. -1 times 1 is -1. -2 plus -1 is -3. -1 times -3 is +3. I add these two together, -13 and +3, I get a -10. -1 times -10 is +10. I add those two together, I get a +24. -1 times 24 is -24. And sure enough, as promised, I get a 0 as a remainder. Now, what I've done is I have depressed this polynomial. I've depressed my original polynomial by 1 power, and my new polynomial has a highest power of 3. So my new polynomial is x cubed minus 3x squared minus 10x plus 24. The thing to remember here, if I go back and I now do my original polynomial with the factor of 4, I'm going to have, again, at the end of the day, a polynomial with a highest power of 3, and that's not really going to help me. I know that this is a factor of my original polynomial, and I know that if I wanted to get to my original polynomial, I would just have to multiply this times x plus 1, because I factored out an x plus 1 when I did my synthetic division. Well, if I factored out an x plus 1, and I depressed my polynomial, I'm making a depressed face right now, what I want to do is I want to take my next factor, and I want to depress my polynomial even more, because I want to get this down to be a quadratic. If I can get it to be a quadratic or even a linear, then my factoring is going to be easy. And I've told you that we have a factor of 4. So let's take my coefficients here. 1, -3, -10, and 24. Let's divide that now by my factor of 4, my 0 of 4. Bring down the 1. 4 times 1 is 4. 4 plus -3 is 1. 4 times 1 is 4. -10 plus 4 is -6. 4 times -6 is -24. Bingo. Another 0 there. Now I've depressed my polynomial into a quadratic. It went from being an x cubed. I pulled out a power. Now it's going to be an x squared. X squared plus x minus 6. Well, I'm looking at that. I'm saying, well, I think I can factor that. And in fact, I can. I can factor that into x plus 3, x minus 2. Now, you could have done that with the quadratic formula, or you could have done it with the surefire method, however you wanted to do it, but that's what you would have ended up with. So these two are factors of that, have my original factors of x plus 1 and x minus 4. X plus 1, x minus 4. So this is my entire polynomial. I already know that, that 4 and minus 1 are zeros, but now I can also see that 2 and negative 3 are my other zeros. So the key to this is to realize that if I give you two factors with a polynomial, however many factors I give you, if I tell you that these are factors, there's a 10-minute bell. If I tell you that a certain couple of binomials are linear binomials, are factors of a polynomial, you want to do synthetic division to depress that equation as far as you can get. And in this case, we were able to depress it down to a quadratic, right here. We were able to depress it to a quadratic. Maybe it would have only been depressible down to a cubic or a quartic. And if that was the case, then maybe you'd have to use grouping or some other method to try and factor. But in this case here, we got it down to a quadratic. So to find the additional zeros, once we got it down to a quadratic, was not so tough. And this synthetic division that we did in the beginning, because I had the remainders of 0 here, showed that the factors that I said were factors were in fact actually factors.